Thanks for joining. For those of you who don't know who I am, my name is Mickey McDonald, and I'm a technical evangelist here at Microsoft Canada. So in this session, we're going to talk a little bit about performance and optimization and how we can, build our apps to better use the devices and do some cool stuff. So we'll jump right in. And this is our agenda for this session. First thing we're going to do is we're going to talk about performance optimization. After that, we'll talk a little bit about low memory and hardware constraints. Followed up, if we have enough time, we'll do a quick Q&A. So getting right to it, our first section is performance optimization. Now obviously, optimization is a huge topic. Well, every app has unique implementations. There's certain things that we can do to help improve performance and memory usage. This becomes especially true when we're working with apps that have been updated from previous versions of Windows. One example of memory optimization that we can take a look at is lowering our app peak memory. Now, our app peak memory consumption is important for a few reasons. One, when we're running on lower memory devices, we don't have as much memory to use, so we got to keep our peak memory down as best we can. Even more important is something like when it's running in the back, or when we're writing background agent code. So if we are using too much peak memory, we can't actually run the background agent code. So it's really important that we keep a really good eye on how much app peak memory we're using. And last but not least on this is execution. Now, as a developer, we have to keep an eye on our app's peak memory consumption. Like I said, very, very important. We can minimize hitting our peak memory by avoiding a few things. Something like intensive loops is a good way to lower our app's peak memory usage. And there, of course, we have a lot of tools, if we skip ahead here, that we can use to really help us out with this. The new Visual Studio stuff has some great things in there, like we have our store test kit, which will actually test to see, one, if we're going to pass certification, and two, will let us know if we're going to hit any major roadblocks when it comes to our app designs. Another major thing that we can do there is sorry, we had a little technical glitch there. Our app analysis inside of Visual Studio, and we'll get to that in a little bit. But right off the bat here, you'll see on our slide, there's a couple of things that we can do for optimization. The decode pixel width and decode pixel height allows us to really set the size of the images that we're downloading, which will in turn lower the amount of memory that we're using. And I'm going to show you an example of this coming up very, very soon. Another thing we have to worry about is leaks. Memory leaks are a big problem. So you want to make sure that you go through and check to make sure that you don't have any dead objects, that you're handling events properly, that you're disposing of objects. Now, growing up, my parents used to always tell me, clean up after yourself. And that goes true when you're building your apps, right? Make sure that whenever you're using something and you decide that you don't need it anymore and you dispose of it, that you're actually cleaning it up properly and you're helping the garbage collector out, right? So that's very, very important to help free up memory. So make sure every time you dispose of an object that you're doing it and handling it the proper way so you can free up the memory that you're using for that object. Another big thing is scrolling performance. Now, a lot of us are used to using ListBox. ListBox works great, but there's a better one if we have a lot of list objects or a lot of complicated objects inside of the list. So if we use something like long list selector instead of ListBox, that's actually really going to help our performance. We want to simplify our item template as much as we can. So like I said, if we have really complex objects inside of our list, it's going to slow it down. So if we can find ways to basically simplify those item templates, we're going to save ourselves a lot of memory there too. And of course, we can do things like virtualized stack paneling and virtualizing panels. Another thing that we can do to take a look at where our optimization and issues are happening is we can do screen redrawing. So there's some code that gets stubbed into your app automatically that's commented out by default. But if you uncomment it, you can actually see what items are being drawn on the screen when. So you can see how many times your screen redraw is being updated. So, maybe there's something on the screen that stays static for the majority of that screen view. If we're redrawing it every single update, that's a huge hit in performance. So by enabling this, you can actually see it. It'll color code it. And again, I'll show you this in a few minutes. But that's a really good way to optimize our screen redraws. Another thing is you got to watch the way you're using converters and data binding. There's a lot of ways we can optimize that. And again, I'm going to show you some really cool stuff around that. So again, I was mentioning the tools. The Store Test Kit allows us to identify potential problems when it comes to certification, as well as like when it's loading up, how long it's taking to boot, and stuff like that. But there's even better tools inside of Visual Studio that we can use to actually profile. So we have things like memory profile and performance counters that really let us see what's going on, and I'll show you exactly how to use that. And as well as it's important to test all this on a real device, right? At the end of the day, the emulator's great. We're going to see all this on there. But the emulator is running on really fast hardware, right? Like something like this Alienware that I got sitting in front of me has got a little bit more power than your Windows Phone might. So, at the end of the day, let's take it out, let's put it on a real device and test it there, and you'll get a really good feel of how it's going to run. And you should do that on both low and high memory devices. So, test it on the Nokia 520 or test it on the Nokia 1020, right? Hit both sides of the spectrum so you can really get a feel for how your app's going to perform. So with that, let's jump right into a demo, and I'll show you some of the stuff that I was mentioning and how you can implement it. So the first thing I'm going to do is I'm going to go ahead and I'm going to run this app with our profiler hooked up. So if I go up here to debug, and I go start Windows Phone application analysis, or hit Alt F1 for a shortcut, it'll come up here and you got a few different options. So we got things like execution, so we can check for profile on execution. We can just profile the memory if we want to. But in this case, we're actually going to do a complete app analysis to see how our app's performing. So if I click here down where it says start session, it's actually going to fire up my app. We'll take a look here. So here's the app. It's just a very basic weather forecast app, nothing too complicated with it. But if I go ahead and I click Redmond, it's going to bring up this really nice list shortly. There we go. So here's our list. And this is a complicated list, and it's fairly long. So if we scroll through it, we're going to be using our memory. So there we get to the bottom of the list. There we go. So now if I go back out of this, I'm going to hit the back button twice to exit the app. And we go back into our Visual Studio. You'll see after a few moments, it's actually going to bring up our data. So right off the bat, the first thing we have here is startup time. So obviously how long the app takes to boot. Our app responsiveness, in this case we didn't have any metric on that. Our total data upload, so how much data we've actually uploaded from our app. Our total downloaded, so how much we've actually downloaded. Our battery charge remaining, so this tells us how much battery drain we've got going on. So right now our app is using, that session consumed 1.54. So the battery charge at this rate would last approximately 11.26 hours. Then if we scroll down a little bit more, we've got our max memory used. So how much memory we used, and this is our peak memory usage. And then we have our average memory used. So how much average memory we were using during the time we were running that app. So that's our baseline. That gives us our baseline metrics. So now we're going to take a look at a couple of techniques we can use to lower the amount of memory we're using and save ourselves a little bit of battery life. So I'm going to go ahead and I'm going to open up my views here, and I'm going to go to my forecast page. Double click and open that. Hopefully that's nice and easy to read for you there. I'm going to scroll down to my list box item template. And this is where we're basically, when we make that list, we're calling all this, and we're calling this every time for every object. So that's going to cause us to use a lot of memory. So the first thing we can do, and you'll notice here that we have our image, and we're defining it as a height of 64 and a width of 64. Now, as developers, we can't really change the amount, the size of it as it's downloaded. But what we can do is we can actually set it so that we won't, we can set the default so that it'll always be the same size. And therefore, no matter how big the image is, we're only going to use the memory that requires us to store a 64 by 64 size image. So if you look here at our bitmap image right there, I'm going to scroll to the very end. And right before the ending /, I'm going to put a couple of pieces of code. So I'm going to write decode pixel height. I love Visual Studio and the fact that it auto-completes for me. It makes my life so much easier. And then after that, we're going to put decode pixel width, and we're going to set that to 64. And like I said, what this is going to do is it's going to make sure that we're only going to render the image at 64 by 64, no matter how big the image is. So if we had a 128 by 128 image, it's only actually going to be rendered at 64 by 64, which actually increases memory, or decreases memory consumption, and it'll actually increase our battery life. So I'm going to save that, and just to prove to you that it works, we're going to run this again. So I'm going to go back up to my debug, my Start Windows Phone Application Analysis. I'm going to fire up a new session. Oh, white space is missing. Okay, let's check there. Oh, a little quotation mark there. There we go. Nope. And we should be good with that. So we'll go back and we'll run again. Hopefully this time with no errors. Ah, beautiful. So now our app's running. And I'm going to do the same thing. I'm going to click Redmond and load the list. Now you'll notice there's no change in the appearance at all. In fact, if I scroll, everything looks the exact same. The app functions the same way. Nothing's changed in that regard. Then we got down to the bottom. And this time I'm going to go ahead and back out. And back inside of Visual Studio, after a second, it's going to parse the log file. And I'm going to bring these up side by side so you can actually see the difference. Oh, that didn't look too good, does it? Okay, well, I'll scroll down just so you can see it. So there we go. Total data uploaded. So our total data uploaded was a little bit more, but that's mostly because I ran the app for a little bit longer. Our total downloaded, it's the same. Scroll down a little bit more. We got our battery charge remaining time. Oh, see, there we go. We actually used a little bit more battery than I thought we would have, but again, I ran the app a little bit longer, so that might have made it drain a little bit more battery off of it. We get down to our memory used. And there we go. So right there you can see we've made a huge performance increase right there. So originally we were using 23 megabytes. Now we've got it down to 17. That's pretty good for a very small fix, right? And our average memory use, of course, is a little bit lower. So that's one way that we can save some memory. Another way that we can save some memory is to change the way we're using the parsing and converters. So we're going to go back over here to our forecast page. And you'll notice right now we have our binding as our converter type right there, static resource conditioned to icon converter. So that's the converter we're using right now. And one way we can get a little bit more performance increase is to actually use the type of, or change the type of converter we're using. So what we're going to do is we're going to go to our URI source, and we're going to change all of this in here. And this time we're going to use a little bit different method for our converter. So I'm going to type this out. It's going to be binding condition Be good if I could spell. Icon. And what this is going to do is this is going to basically save the amount of memory that we have to use each time we generate an item. So before, every time we were generating an item, we were calling this again and causing us to use more and more memory. This time, we're actually going to generate everything right off the hop. So again, actually, you know what? Before we run it again, let's make one more change. Let's change the fact that we're using the list box. Like I said before, list boxes are great, you know, but once you start using longer lists, or you've got a lot more items inside of your list, or the items are very, very complex, list box starts to chew up the memory. So we have an alternative for this, and if I click list box here, we're going to change everywhere where we see list box. There's actually 4 spots, and you'll see when I change them. We're going to change this to say phone, long list selector. Now, because I changed that there, I'm going to need to change it down here. So I'm going to grab that, copy it, and I'm going to drop it in here. Oh. I think I should erase that there. Let's just try that again. Oh. It's the fun of coding live. And we'll grab this, and we'll change that. So there you go. And the great thing about Visual Studio 2013 is it actually knows that I'm changing those and goes and changes my closing tags for me. Very handy feature. So there we go. Now we've changed the list box to use a long list selector, which is going to help us out. It's a little bit more CPU friendly and has better performance scrolling. So let's fire this up and see what we've gained. So I go back to debug, I go to start Windows Phone application analysis, start it up again, go to our emulator, and you'll notice here that, you know, same thing, nothing looks different, everything looks the same, acts the same. You can scroll, scrolling acts exactly the same way as you would expect. Icons, no change. And there we go. So we got to the bottom. Again, I'm going to back out. We go back here. Now I'm going to open up the original one that we had so we can see them side by side again. So our startup time actually increased a little bit, or decreased a little bit, sorry. And we scroll down, our total uploaded data. So we had a little bit extra data, but again, because I'm running the apps at different lengths of time, it's going to be a little bit different for that. Total downloaded data is the same. We scroll down, we got our battery charge. So there we go. So we're saving a little bit of battery right off the hop. That's good. Scroll down a little bit more, get to our memory. And there you go. So this is our new one. I should have put them in the proper order. Let me flip that so it looks better. There we go. Scroll back down. So there's our max memory used for that, and our max memory used from our original. So there we go. As you can see, we've decreased the amount of memory we needed to use. Performance is a lot better. Our CPU's getting a little bit lighter of a load on it, as well as we're saving some battery life. So a couple of quick little changes there. Again, the end user doesn't notice anything different other than the fact that it'll actually perform a little bit faster, especially when you start pushing this out to a low-end device. You'll actually start to see the difference. But overall, that's a couple of quick ways that we can change that. Now, I mentioned before the fact that there's some commented code inside of our default template that is set up so that we can see things colored as they're drawn. So I'm going to go ahead and show you how we can use that. Okay, so we're going to go into our app SAML.cs file, and we're going to scroll down here until we hit our debug code. And you'll see right here we have application current host settings enable redraw regions. So if we uncomment that and we run the app again, you'll notice now every time that it updates and it redraws, it's going to change the color of the screen. So every time we get a new ad, as you can see here at the bottom, we're drawing the entire screen. And that's not very good for performance, right? So let's take a look at a way that we can set it up so we're not actually going to redraw the static stuff on the screen, only redraw the stuff that's changing. So we'll close this out. We'll go back into our code. And we're going to go into our views and into our main page. I'll make it easier for us to see this. We're going to scroll down until we find our sample ad controller. There we are. And at the end of our sample ad controller, we're going to add a little bit of code just before the closing /. So here we're going to put in cache. Oh, sorry, I'm still running. There we go. We're going to put cache mode, and we're going to give it the value of bitmap cache. All right, now if we run the app again, you'll notice that our static content here, the color never changes, but for our ad, it changes. So that's one huge increase for performance when we're redrawing objects. I always find that one very, very easy and cool. So another thing we can do before we wrap this up is we're going to take a look at the background handler, so our background agent. Now, our background agent actually only gets access to 11 megabytes of memory per app. So the demo, when I go in here, if I go into my magic here, see the live tiles, you'll notice that these tiles, when I create them, is actually creating 14 megabytes, a little bit over 14 megabytes. So if we were to leave this the way it is, our background manager actually can't update these tiles. So what we want to do is take a look at a way that we can change this so we're using less peak memory and get it down to a point where we can actually use the background agent. So we'll go back into our code. And just because I don't want to cause any issues, I'm just going to comment that back out so we don't have a funky color thing going on. And I'm going to go into the title page over here. And I'm going to open up the code behind for it, so the title page xaml.cs. And I'm going to scroll down to where I'm actually creating the tiles. And the way we have it set up right now is we're creating each tile independently. So every time we call this, we're creating a tile by itself, one after another. So one way we can change this and increase a little bit of performance is to actually put it into a queue, so that we're going to basically call them all at once and it'll queue them and therefore save us a lot of memory and actually increase our performance. So thankfully I don't have to type this all out, I've got it all commented to begin with. So I'm going to comment this code and I'm going to uncomment the other code. There we go. Now if I run it this time, and we go back to our tile page, you'll notice we've dropped that down to just over 5 megabytes. So that's a pretty good decrease. And this will actually allow us to run the background agent on it. And no difference. The user's not going to see anything different when it comes to the app. But right there, we've already made a huge stride as it comes to peak memory. So that's it for this demo. So I'm going to jump back into our PowerPoint. And we're going to move on to low memory and hardware constraints. So obviously, not all Windows Phone devices are born equal, right? We've got high-end devices like the Nokia Lumia 520 with 2 GB of RAM and a huge, 1080p screen. But we also have lower-end devices such as like, the Lumia 520 that has a WVGA screen and only has 512 megabytes of RAM. There's also a couple of different things. Like there's things like the fact that we only have, that there's like the 41 megapixel rear camera on the Nokia 1020. And then if you take a look at something like the 520 or the 820, that drops down to a 5 megapixel camera. You've got some devices that have a front-facing camera. You've got some devices that don't. You've got devices that have compass support or NFC readers. And you have some that don't. So this is very important to think about when you start to design your app. You want to make sure that you're targeting and thinking about this and making sure that you're targeting the proper components. So mostly the major thing that we want to think about is the fact that we're limited in memory size. When we're targeting breadth, so when you're targeting everything, you want to aim for the lowest common denominator. So basically, we want to target the lowest end device that we can run on. Alternatively, you can do something like selective targeting, where you're targeting specific hardware. So if you have an app that requires the use of NFC, you're going to want to make sure that you're only targeting devices that use NFC. And the good thing about this is the Store app on the devices will actually make sure that you're if you're only targeting something like, so if you have a requirement for NFC and the person's device that's actually searching the store doesn't have NFC, it won't even show up in the store. So the good thing about this is you won't get users downloading it, trying to use your app, and they're having issues, and then they just destroy you in your ratings. So that's a really good thing about the store. Another thing you might want to look at is regional or market targeting. So, obviously every region and cultural has different ideas of what's acceptable to users. So you might have something like your app might be perfectly acceptable in Canada or the US, but it might not, some of the features might not be acceptable in other cultures. So that's something that you want to keep in mind when you're building out your app. If you're targeting a specific culture or country, that you only include things that they're going to find okay. You can also target, like I said, subsets via the hardware in that, and like I said, the store will basically take care of that stuff for you. Overall, ensure that your users are having a great experience, right? At the end of the day, you want to make sure that you're giving your users the best experience on that device that you can. So this is a nice little graph that kind of explains the split when it comes to Windows 8 devices around the world. You'll notice that the lower end devices are actually 65% of the Windows Phone 8 devices out there. So it's very important if you want to hit as many people as you can to target the lower end devices. And here's just a nice shot of some really good devices. The 520 is very, very popular. In fact, and when I've got my analytics running on my apps, I've noticed that I'm getting the majority of my users are actually coming from the 520 and the 8X as well. So the lower memory devices are actually doing very, very well for me. Of course, Windows Phone has strict memory caps and quotas. The resource manager for this is obviously going to handle most of this. You want to make sure that you're working with this the best way you can in order to give that experience. Like I said, you want to make sure it doesn't matter what hardware you're targeting or what specific features you're targeting. You want to give the user the best experience you can. So you can do certain things like maybe even offering different versions of your app. Maybe you take out certain hardware requirements or make them optional. Those are ways that you can still target everyone and give that really cool experience to people that have the devices that can actually go ahead and use your stuff. But overall, just make sure that you're trying to strive for that best experience across all scenarios. This is going to show our memory cap. So you'll see here for voice over IP on the 512 megabyte phones, we're only actually getting access to 51 megabytes. That goes up to 60 on the 1 gig, stays at 60 for the 2 gigs. Our background audio gets 20 across the board. Our generic background agents, so like I said before, the background agents running in the background, for the lower end devices, it's at 11 for the cap. When you get up into the higher ends, with update 3, it actually goes up to 25 on the 1 gig and the 2 gigs. So that's really cool. Our foreground app, so this is our app that's running, either through XNA or native, we get access to 150 across the board. And if we're using XAML or .NET for our foreground app, we get 150 for the lower end devices and 300 for the higher end devices. So the best way to do this is we can use memory APIs to check our usage and actually see where we're using the most memory. We can actually go ahead and set inside of our app manifest requirements. So in this case, we've got up here on the slide, you've got required memory 300 megabytes. So if we have this selected inside of our app manifest, we're saying that we're only going to run on devices that have at least 300 megabytes of RAM. So here is a little bit more in detail about that. So here we have, if we want it to have a minimum cap of 150 but does not exceed the maximum cap of 180. So this is our lower end devices. This is the mitigation that we'll set inside of our app manifest. This allows us to opt out if we want to. So if we go down below, we're saying that we're going to always exceed the minimum memory cap. So we want to select the mitigation for ID underscore required memory is 300. So this says that only devices that have over 300 megabytes can actually run this. So we're opting out of the low memory devices. And then if we go down here, this is our extends high memory cap. So we're saying that we want to have access to the extended memory and that we won't run on any device below, I believe is actually 180. And we get a max cap of 380. And then if you look at the 2 gig devices, we can go all the way up to 570. So that's how you set that inside your memory cap options inside of your app manifest. I'm just checking a question here. Is there a way to get into low power mode? Off the top of my head, I'm not 100% sure on how you would go about doing that. But I will follow up with you afterwards to see if we can come up with an answer for that. So now I'm going to show you, like I mentioned before, there's a couple of ways that we can go ahead and see how much memory we're using. So I'm going to show you a neat little demo that will show us how to release and grab memory. So we'll jump over into our code here. Okay. So the first thing I'm going to do is I'm just going to run the app so you can see it. Just fire it up here. Oh. Have to close the previously running app. There we go. So we run it again. Fire up our emulator here. Takes a second. We're deploying our application. It's because I closed out the emulator and fired it back up, so I had to reboot it all. And there we go. Our app's going to boot up. And this is basically just showing us how much memory we're using fixed. So right off the bat, how much memory our device has. So I'm using the lower end device emulator. So right now we have access to a total of 511 megabytes. Our commit limit is 150, so we can't go over the 150. And again, our working set limit is at 150. And then our app peak right now, we've only used 5.4 megabytes. So those are basically what we're going to keep an eye on. And I'm going to show you in code how we're actually using that in the calls to the API, where we're getting these numbers from. So I'm going to back out of this. I'm going to go into my main page code behind. I'm going to scroll down to my get fixed memory limits. And the first one is the device total memory. So right here, if you can see the code, this is how we're pulling in that number for the total memory. So this is the API call, and we're casting it as a double. And then below it we have our commit cap, and this is the API call right here, device status, application memory use limit. And then we're converting that to a double and putting it inside of a string that we then display. And then if we go below that, this is where we're actually getting our working set limit. So the API call is right there. So that's how we're getting all those values, which is pretty cool. And then if I scroll down to the dynamic memory usage, the ones that actually are going to change, you'll see the API call. So application's current memory usage, there's the API call for that. Scroll down a little bit more, we have our application peak memory usage, which we'll display there. And our current commit, so we can actually see our total memory, which is just right there. That'll actually get our total memory. So that's how we're pulling in that data. So let's jump back over, and I'm going to show you how we are actually consuming and how we can consume and release and what happens when we hit our limit. So we'll go ahead and fire this up again. Now you'll notice the values are all the same, but as soon as I click consume, you'll notice that our managed heaps now changed, our app peaks changed, and our app currents changed. So now if I release, we'll get some memory back. Our app peak stays at 20 because that's the highest we went, but our current drops. So if I click this a bunch and we get up close to our limit, as soon as we hit 120, we've set it so it changes the color to yellow. So this is kind of like the caution zone. When you get up to about 121, you're really at that point where you should start making sure you're releasing memory. And if we keep clicking and we hit 140, we actually turn red. Now, if I keep clicking consume, I can't consume any more than 141. But you'll notice over here in my output, I'm actually throwing an exception. I'm throwing an out of memory exception. Now, if I didn't have a catch statement inside my code, this app would actually be crashing. So it's very important to keep an eye on how much peak memory you're using inside of your app. So I thought that was a really good way to show you, basically what happens when you hit that point, right? There's not just this ceiling that you hit it and everything just keeps running. You actually go over the 150 in this case, or 140 in our case, it'll start to throw exceptions. So I highly suggest, if you are worried about it, you do put a try catch statement in there so that you can catch it and you don't just throw the exception and have your app crash. So we'll go back to our presentation now. And that pretty much wraps it up. Now, there's a lot more out there than what we just covered. Obviously, there's a lot more than tips and tricks out there than what I've shown you. So some really good resources are around memory limits for the Windows 8 phone. You can find that link there, as well as some tips and tricks and some best practices when it comes to developing apps for lower memory phones. Best practice tips for delivering apps with 256 megabytes, so even lower than the 512. And optimizing apps for lower cost devices. So really, really good stuff there. Well, that's great. Then let's go ahead. We'll take a break, take a 10-minute break, and when we come back, we'll talk some testing.